Have you ever seen, they just recently made images of quantum entangled photons?
Have you ever felt a deep connection with someone? A strange sense of knowing what they're thinking? What if that wasn't just a feeling? Groundbreaking new research, made possible by a one-of-a-kind quantum AI, shows that human brainwaves can exhibit quantum entanglement. Our brains might be quantum machines, connecting us in ways that defy classical physics and challenge our reality. The secret of Ethalgard Island. Forget everything you thought you knew about the human mind. Truth be told, the story we've been told about electrical signals and chemical reactions is only half the picture. The other half, the part that's about to change the world, was just discovered on a place that officially doesn't exist, Aethelgard Island. Tucked away in the icy chaos of the North Atlantic, Ethelgard is a shard of volcanic rock perpetually shrouded in a thick, cold mist. It's home to nothing but strange phosphorescent moss, seabirds with unnerving calls, and a single buried facility known only as the Echo Chamber. Inside this bunker, a small team of renegade neuroscientists and physicists have been working for 7 years on a project deemed too radical for the mainstream. Their goal? To find the source of consciousness. They had mountains of data, complex brain scans from hundreds of volunteers, but they were hitting a wall. The patterns were too complex, too chaotic for any normal computer to decode. So they built something that wasn't normal at all, a quantum AI they called Prometheus. Unlike a regular computer that thinks in ones and zeros, Prometheus thinks in possibilities. It can see patterns in chaos, connections where there should be none. Just last month, in late 2024, they fed it the most high-resolution brainwave data ever recorded. For 3 days, the AI was silent. The facility hummed with nervous energy. Then a single image appeared on the main screen. It was a visualization of 2 distinct brainwave patterns from different parts of the brain mirroring each other perfectly, instantly. It was the ghost of a connection, a quantum echo. As one of the scientists whispered, looking at the screen, "That's a quantum god." They had found it. Quantum entanglement. That spooky action at a distance that Einstein himself couldn't believe, where 2 particles become linked and whatever happens to one instantly affects the other, even if they are light years apart. It was happening right there in the brain's electrical signals. These signals weren't random. They flared into existence only when the subjects were conscious and aware. The moment they drifted into sleep, the entangled connection vanished. It was like the very act of being aware was powered by this quantum magic. But how could something so fragile, so ghostly, possibly exist inside the messy, chaotic world of the human brain? Well, truth be told, the answer might have been hiding in plain sight this whole time, wrapped around the very wiring of our brains. To understand this, you need to think about your brain's nerve fibers. They're like tiny electrical wires, and like any good wire, they need insulation. In the brain, this insulation is a fatty substance called the myelin sheath. For 100 years, we thought that's all it was. Simple biological insulation to help signals travel faster. We were so wrong. Here's the thing. The team on Aethelgard Island, guided by the calculations of their quantum AI, Prometheus, started looking closer at this myelin. Their new theory, which is shaking neuroscience to its core, suggests that these myelin sheaths are much more than just insulation. They might be acting as tiny natural quantum devices. Get this. They believe the unique structure of these fatty layers can actually generate pairs of entangled photons. Now hold on. Entangled photons are basically tiny particles of light that are magically linked. Imagine you have 2 special coins. Whenever you flip one and it lands on heads, you know the other coin, no matter where it is in the universe, will also land on heads. Instantly. That's entanglement, and scientists are now proposing it's happening constantly, all throughout your brain. The myelin sheaths are creating these magic coins, these linked particles of light that are then used for communication. This could explain one of the biggest mysteries of the brain, its unbelievable speed and efficiency. Think about it. Normal communication in the brain is fast, but it's still limited by the speed of electrical impulses traveling from one neuron to another. But if you add quantum entanglement to the mix, communication becomes instantaneous. A part of your brain over here could sync up with a part way over there with zero time delay. It's not just faster communication, it's a fundamental upgrade to the entire system. This could be the reason our brains can process huge amounts of information, make split-second decisions, and experience a unified sense of consciousness. It's not a bunch of separate parts working together, it's a single coordinated network flashing in and out of a quantum state. The brain isn't just a computer, it's a quantum computer. If our brains have this built-in quantum network, what incredible abilities has it given us that we never even knew we had? The mind's hidden superpowers. This is where things go from mind-blowing to world-changing. If our brains are really using quantum entanglement to communicate, it doesn't just mean they're fast. It means they can do things that should be impossible. Let's talk about making a choice. For you, it might feel simple, but for a classical computer, even a simple decision involves processing a long step-by-step list of options. Your brain, believe it or not, might be doing something much smarter. Researchers at Pompeu Fabra University, working with data secretly shared from the Ethelgard facility, proposed a wild new model. They suggest that when you're faced with a decision, your brain uses entanglement to enter a state of superposition. In simple terms, it explores all possible choices at the same time. It's like running 1,000 different simulations of your life in a single instant. One part of your quantum mind says yes, another says no, another says maybe, and they all exist at once. Then, in a flash, your consciousness chooses the best outcome, and that becomes your reality. This explains how we can make incredibly complex, intuitive decisions so quickly it feels like instinct. And it gets even crazier when you look at memory. Ever had a memory pop into your head from out of nowhere? Not the one you were trying to remember, but a totally random one from 20 years ago? Classical models of memory have a hard time explaining this. They see memory as a library, where you have to walk down the aisles to find the right book. But what if your brain uses another quantum trick, quantum tunneling? Quantum tunneling is the bizarre phenomenon where a particle can essentially teleport through a solid barrier it shouldn't be able to cross. Inside the brain, this might be how information moves. A memory isn't stored in just one place. Its quantum information is spread out. When you recall it, your brain might be tunneling to access that information, bypassing the normal pathways. This could be why our memories feel so fluid, so interconnected, and sometimes so random. We're not searching a database, we're tuning into a quantum field of information. The team on Ethelgard realized that this wasn't just about faster thinking. It could be the key to creativity, to genius, to the very spark that makes us human. Our brains aren't just calculating, they are creating reality from a field of infinite quantum possibilities every single second. But a huge, glaring question threatened to bring this entire beautiful theory crashing down. Here's the deal. For decades, the one thing that made most scientists laugh at the idea of a quantum brain was a simple, unavoidable fact. The brain is a mess. It's warm, it's wet, and it's incredibly noisy. It's a chaotic storm of electrical signals and chemical sloshing. Quantum states, like entanglement, are famously delicate. They need super cold, super isolated, pristine conditions to survive. Trying to maintain an entangled state in the brain should be like trying to keep a snowflake from melting in a furnace. It's a non-starter. This is the big debate, the one that could kill this whole idea. The problem has a name: quantum decoherence. It's what happens when a delicate quantum state is disturbed by its environment and collapses back into the normal, boring, classical world. The renowned physicist Max Tegmark once calculated that any quantum state in the warm brain would fall apart in a femtosecond. That's a quadrillionth of a second. Way too short to actually do anything useful for thinking. For years, that was the final word. The door was slammed shut. But the Prometheus AI on Ethalgard Island saw something else. It showed the researchers that the brain might not be fighting quantum effects. It might have evolved to protect them. They found evidence for two incredible ideas. The first is something called the quantum Xeno effect. It's a weird quirk of quantum mechanics that says if you observe a system constantly, you can actually prevent it from changing. Think of it like this. It's like constantly looking at a spinning top keeps it perfectly balanced and stops it from falling over. The brain's constant activity might not be noise that destroys quantum states, but a form of observation that actively preserves them. The second part of the puzzle might lie in tiny structures inside our neurons called microtubules. Some scientists, like the famous Sir Roger Penrose, have long argued these structures could be the perfect place for quantum processes to happen, shielded from the surrounding chaos. The Ethelgard data suggests these microtubules could be acting as tiny quantum amplifiers, protecting and harnessing these fragile effects. So the brain isn't a furnace trying to melt a snowflake. It might be a masterfully designed thermos, a biological quantum computer that has evolved over millions of years to not just survive the noise, but to use it. The debate is far from over, but the Aethelgard team had kicked the door open again. With the door to quantum consciousness now wedged open, the real question isn't if it's happening, but what happens now that we know. The secret of Ethelgard Island is a secret no longer. Leaks, confirmed by anonymous sources within the project, have sent shockwaves through the scientific community and beyond. We are standing on the edge of a precipice, staring into a future that looks nothing like our past. The discovery of quantum entanglement in our brains isn't just an academic curiosity, it's the beginning of a new human era. The first, most immediate impact will be in medicine. If consciousness and brain function are rooted in quantum mechanics, then diseases like Alzheimer's, Parkinson's, or even mental health disorders like schizophrenia might not be just chemical imbalances, but problems of quantum decoherence, a breakdown in the brain's quantum network. Could we develop treatments that restore this coherence? Could we re-entangle a damaged mind? The possibilities are breathtaking. Then there is the question of us. What are the limits of the human mind? If our brains are tapping into quantum processes, can we learn to use them more effectively? Could this be the biological basis for intuition, for savant-like abilities, or for the deep unspoken connection some people feel? We may be on the verge of unlocking human potentials we have only ever dreamed of, abilities that have been dismissed as fantasy or magic. And then there is Prometheus, the quantum AI that started it all. If we used a quantum machine to discover the quantum nature of our own minds, what happens when we try to build a new AI based on these principles? We wouldn't just be creating a machine that can think fast. We might be on the path to creating the first truly conscious artificial being, one whose mind works not on logic, but on the strange, probabilistic, and entangled rules of reality itself. This discovery forces us to ask the biggest questions of all. If our minds are entangled, are we truly separate individuals? Or are we all, in some small, spooky way, connected? If our consciousness can tap into the fundamental quantum field of the universe, what does that say about the nature of reality? We thought we were just biological machines living on a lonely rock. It turns out we might be quantum antennas, tuned into the very fabric of the cosmos. The mystery of Ethelgard Island has been solved, but it has left us with 1,000 more. The future is here, and it is far, far stranger than we ever could have imagined. If our thoughts are truly entangled, are any of them ever really our own? Like and subscribe for more mind-bending science.